Good morning, viewers. I welcome you to today's class. Last week we discussed about differentiation from first principle, but today we're actually going to be talking about differentiation from common functions. Now, when you talk of common function is being generated from first principle. That is, it generates with a general rule, and that general rule is simply y is equals to a n x n minus one. That is, a and n, they are said to be a constant in this case. That therefore, let's assume we are given y is equals to x squared. Now, in my last video, I did this example using first principle. Now you can visit that channel and try to cross-check. If you are to solve this with this formula, with this general rule, you are going to arrive the same answer as the first principle. Okay. Now, given y equals to x squared, how do we get the y the x here? Now, remember, I didn't say the p the q, because I didn't have p and q. I actually have y and x. So I can say the y dx of this is equals to, now, if you are to use this formula here, we need to generate some parameters out here. Like I said, a and n, they are said to be a constant. So my a in this case is simply the coefficient of this x squared, which is 1. Then my n is simply the power, which is 2. So if I replace these two values back in this formula, I'm going to have the y dx equals to a, which is 1, times then n, which is 2, x, n, which is 2 minus 1. And this simply gives you 2x. That is my dy dx. Now, another case, if you are given y equals to 10x cubed, okay, let's call it b and let's call this a. Of course, my a again is simply the coefficient, which is 10. Then my n is simply what? 3. So if I place these two again in this particular formula, I'm going to have the y dx to be equals to a, which is 10 in this case, times n, which is 3, then x, n again, which is 3 minus 1. And this will give you 10 times 3, that's 30x squared. Okay. But these are just a brief of common function. But let's go to trigonometry, whereby you have the sine and you have the cosine. How do we solve that using this differential from common function? Okay. Take for instance, we have y is equals to sine x. I want to get out the dy dx of this function. Okay. Now in that case, sine x will change to cos x, because from a sine graph changes to a cosine wave, cosine graph. Let me use that word now. If y equals to sine x, that means the y dx of sine x is simply what? Cos x. That's from a sine graph. Okay. Now, also, that means if you are given y is equals to sine 2x, how do we handle this? It is very simple. Already we have established a protocol here that sine x changes to what? Cos x. How do we handle sine 2x? We simply do this. The y dx is equals to, now we know that sine changes to cos. We write the cos here. Then the function at the front, which is 2x, will differentiate that function. When you differentiate this function, you simply have 2. Put the 2 here. How we have 2 is this. When you have 2x, same thing as 2x raised to the power 1. So you multiply 1 times 2, that's 2. X 1 minus 1. Don't forget, from that general formula, that y equals to x. So we still have 2x raised to the power 0, and anything raised to the power 0 is simply what? 1. So the answer is 2 times 1, that's 2. That's what made us to change. Okay. Differentiation of 2x simply what? 2. Then remember, I write sine changes to cos. Then I differentiate this, I have 2. Then this function again, you write it at the front, and that's all. Okay. Now, if y is equals to cos x, also if you are given y equals to cos x, and we have to find the y dx of this, remember this is y equals to sine x. Now it is the reverse of this protocol. So that means if we are given y equals to cos x, we simply have the y dx to be equals to minus sine x. Like I say, is a reverse word protocol. Okay. Now that is, it implies that given that y is equals to cos 2x, right? So the dy dx of this too is just going to be, don't forget, minus, then cos change to what? Sine. Put that first. Then you differentiate what you have at the front, which is 2x. This is going to be 2. Then you write the 2x here, and that is all. Okay. So these are just for sine and cosine. Now let's go to the one of when we are given exponential and natural log, which is referred to as the limb. Okay. Now let's assume we are given y equals to exponential x. I want to find the dy dx. Now, how do we differentiate these two? The rule is, if y equals to exponential x, you differentiate the one on top. If I differentiate x, I will have 1 times the same function. So that means if you are to differentiate exponential x, it's also the same thing as what? Exponential x. So given something like this, y equals to exponential 2x. How do we do this? Like I said, same thing, the y, the x of this. Differentiate this 2x, which is going to give you 2 times the same exponential. So everything gives you 2 exponential 2x. That is all. Now, the one of natural log. The one of natural log, given y equals to ln x. How do we do this too? The y dx is simply equals to, now you differentiate this function, you will forget about the ln. This x you differentiate, you have 1 times, look for the inverse of that thing. So inverse of the function, which is just going to give you 1 over x. Remember, differentiate this, you have 1, then 1 over the inverse of this function, which is this. That is, let's assume we are given y is equals to ln 2x. Same thing, differentiate this 2x, 2 times 1 over this function 2x. So this will eliminate this, so you have 1 over x. Ln 3x will still give you 1 over x. Ln 4x will still give you 1 over x. Ln 5x will still give you 1 over x. But if you are given something like this, something similar to that, so assume we are given y is equals to ln x squared. Now you can see this is quite different from this. This is ln 2 and this is ln x squared. The same thing, you differentiate dy dx of this. When you differentiate this x squared, you simply have 2x times 1 over, don't forget the function again. So this will give you 2x times 1 over x times x. X cancel x. X times x means x squared. So x cancel x, so you are left with 2 over x. So the dy dx is simply what? 2 over x. Okay. Now we can now summarize all these factors in the table. Let's summarize them in the table. The table is simply when we have the function, okay, and we have the what? The dy dx, which is known as derivative. Okay. Now the derivative of this, we are given y equals to sine x. Therefore, the dy, the dx of it simply changes to what? Cos x. Y is equals to sine ax. The derivative, the y dx, is simply, don't forget, a cos ax. C, y equals to cos x. The derivative is simply equals to what? Minus, don't forget cos change to minus, sine x. B, y is equals to cos ax. Then the dy dx is simply equals to minus a cos minus a sine ax. Y is equals to exponential x. The derivative dy dx is simply equals to exponential x. F y is equals to exponential ax. The derivative is simply equals to what? A exponential ax. Okay, that's when you differentiate, you bring this to the back. Then g, given y equals to ln x, the dy dx is simply equals to 1 over x. Okay, and so on and so forth. So because why I stop here is because if I have ln 2x, it's still going to give me ln, it's going to give me what? 1 over x. So these are the common function of that table. Now you can see that this in this particular table there is only like tan there. So that is why you need to just please subscribe to this YouTube channel as to get more updated on the difficult solutions of this differentiation from common function. And we are going to be taking out the next video. We are going to be dealing with the rules that govern each of them. We have some rules like the chain rule, the product rule, the quotient rule that govern each particular question. Thank you very much. As you enjoy this video, I want you please to I want to please try to please like, share, and subscribe to this channel. It's going to be very helpful, and you share to people that you think they feel they need this video because it's a common video, so and it's going to be helpful to you guys. Please, as you view, just simply like, share, and subscribe. Thank you very much, and enjoy the rest of the day. Bye bye.